Hi everyone, I'm Tianshu Hao from Institute of Computing Technology, Chinese Academy of Sciences. Today I'll introduce you at AIBench towards comprehensive end-to-end AI edge computing benchmarking. This is the outline of today's presentation. By 2025, forecasts suggest that there will be more than 75 billion Internet of Things connected devices in use. With the explosive growth of those client-side devices, raw data produced by these devices will be enormous, which makes conventional cloud computing not efficient enough to handle all this data. What's more, using the cloud as a centralized server simply increases the frequency of communication. This figure shows the architecture of edge cloud computing in a distributed cloud environment. We can see the magnitude of devices from each layer. If we put the most of computing tasks on cloud layer, the overhead of data transmission and data encryption among devices and data centers becomes significant bottlenecks. Therefore, it raises a daunting challenge for cloud computing with throughput, latency, security guarantee, and consumption, and so on. Therefore, edge computing architecture emerges as a promising technical framework to overcome the challenges above in cloud computing. The edge computing framework adds a new layer, named the edge computing layer, on the basis of the traditional cloud computing framework. This figure shows the general edge computing framework, which includes three layers: cloud server, edge computing layer, and client-side devices. Edge computing is a new distributed computing paradigm which moves the computation away from data centers and brings the computation and data storage closer to users, so it can improve the response time and save the network bandwidth. Edge computing decentralizes traditional cloud computing to alleviate problems associated with limited bandwidth, latency, and data storage in centralized cloud computing. Moreover, artificial intelligence technology is now widely adopted in edge computing, such as augmented reality, smart city, healthcare, wearable devices, and so on. We simply refer to those edge computing scenarios using AI technology edge AI. There exists a wide range of edge AI scenarios and applications. And edge AI has been identified by Gartner Research as the new thrust of research and development in 2020. However, edge AI is in the initial stage and doesn't have a uniform standard for these scenarios. Therefore, a benchmark suite for edge AI computing applications is needed to measure the performance and help to optimize the framework and applications. But there are many challenges for the edge AI. These AI scenarios are complicated because of the three-layer AI edge computing architecture. The evaluation processing needs to cover the overall architecture and the critical path. Moreover, there are many challenges for benchmarking. How to reflect the three-layer collaboration, considering the critical paths and primary models, so an end-to-end benchmark is needed, and how to reflect the diversity and complexity. Because of the different kinds of client-side devices, a large quantity of heterogeneous data, privacy, and security issues, most of those scenarios have a high requirement for latency and network bandwidth. So, how to reflect the diversity and complexity is also a problem. Although edge computing solves some problems of centralized cloud computing, it also has many challenges because of its complicated scenarios and hierarchical architecture. Based on our extensive survey, we conclude 6 significant characteristics of those edge AI scenarios. These pages show those 6 characteristics in specific scenarios. The first one is accuracy. Some edge computing scenarios need reliability due to their particularity, such as autonomous vehicles. Various tasks have different requirements for accuracy. We take autonomous vehicles as an example. The accuracy of those tasks even need to be close to 100%. Nevertheless, for SU patient monitor, accuracy is not the most important thing to be considered. In our survey, the state-of-the-art algorithms of those scenarios still lack accuracy. The second one is latency tolerance. Actually, most of the edge AI scenarios have high real-time demands, as they are closely tied to human life. For autonomous vehicles, due to their network connection methods, the communication latency can be up to 10 milliseconds using 5G technology. Moreover, the total end-to-end execution time latency can be up to 100 milliseconds. For the ICU patient monitor scenario, the communication latency can be up to 1 millisecond using a wired network. The total end-to-end execution latency can be up to 10 milliseconds. And mobile means that end devices are not static in one place. Mobile edge computing is a crucial technology and architectural concept in edge computing. In our four scenarios, autonomous vehicle is a typical scenario using mobile edge computing technology. In a MEC scenario, keeping network connection and stable state transition are two fundamental problems required to be solved. And usually, one edge server needs to correspond with multiple users. In the ICU patient monitor scenario, one edge server corresponds to multiple patients. In the surveillance camera scenario, one edge server corresponds to multiple cameras. And in smart home scenario, one edge server corresponds to various devices. However, one AI chip only serves one smart car due to the particularity of the autonomous vehicles. And as HRS Market reported, 1 billion surveillance cameras will be watching around the world in 2021. Moreover, it has been calculated that 24 hours of 4K 60 FPS videos take nearly 35 terabytes storage. Therefore, there are enormous data in surveillance camera compared to any edge computing scenario. In edge computing scenarios such as smart home, there are multiple heterogeneous devices, including smartphone, computer, iPad, router, camera, and so on. And those devices will generate heterogeneous data, text, image, audio, video, and so on. Thus, how to processing those data is also a problem needing to be solved in edge AI computing. In our bench console AIBench system, we propose a scenario benchmark. Scenario benchmark is a proxy of a realistic application scenario and a permutation of a series of AI and non-AI components to capture the critical paths and primary modules. Therefore, to answer the question we ask above, we propose a scenario-based benchmark, Edge AIBench. Next, I'll introduce what is Edge AIBench. Based on the above requirements, we propose a benchmark suite named Edge AIBench for Edge AI computing applications. Edge AIBench is the first comprehensive end-to-end Edge AI benchmark framework, and it takes an end-to-end view and divides the task into three parts: cloud server, edge computing layer, and client-side devices. And more information is available on Bench Console Edge AI Bench website. Additionally, There are our publications based on Edge AIBench. In the previous page, we mentioned that Edge AIBench is an end-to-end benchmark. So what is end-to-end? Actually, there are some work about edge computing benchmarking, but they all focus on one layer, such as inference on edge devices. In the edge computing scenarios, the distribution of data and collaboration of workloads on different layers are serious concerns for performance, security, and privacy issues. So for benchmarking, designing, and implementing edge computing systems or applications, we shall take an end-to-end view, considering all three layers and their collaboration. This figure shows the critical path of an AI task in edge cloud computing. From this figure, we can find that both training, processing, and inference need to be considered. When put those processing tasks on different layers, performance will be influenced deeply by diverse workload and data allocation in three-layer edge computing architecture. As some edge or end devices cannot support the complicated computing tasks, collaboration needs to be considered among those three layers. Therefore, the performance evaluation and analysis needs to cover the critical path. This figure presents the construction methodology of Edge AIBench. Firstly, the typical scenarios are extracted to present the numerous Edge AI scenarios, and then the primary layers with macro component and application benchmarks are extracted. In addition, the heterogeneous representative real-world datasets are chosen as the dataset. To organize our benchmark suite, we adopt a scenario-based benchmark view. The scenario-based idea means extracting primary scenarios which can represent the characteristics. Also, those scenarios need to cover all applications complexity in Edge AI computing. Edge AI Bench is a scenario benchmark considering scenarios, characteristics, and typical applications. In Edge AI Bench, we extract four typical scenarios which can represent those characteristics: autonomous vehicle, ICU patient monitor, surveillance camera, and smart home. This figure shows those four scenarios in Edge AI environments. We think they can represent the complexity of all of the edge computing applications. The autonomous vehicle represents the latency-sensitive, high accuracy, and mobile characteristics, and ICU patient monitor represents the latency-sensitive and parallel characteristics, and surveillance camera represents the enormous data characteristics, and smart home represents the heterogeneous devices and data. Now we have 9 typical Edge AI tasks in Edge AI Bench, and this table shows their tasks name, scenarios, models, datasets, and implementation software stacks. Edge AI Bench provides an end-to-end application benchmarking consisting of training, inference, data collection, and other parts using a general three-layer edge computing framework. We give the reference implementations of them, and the open source code now is available. Next, I'll introduce the experimental results of Edge AI Bench. We construct the experimental environment to simulate the realistic cloud edge computing scenario. Additionally, we assume that the cloud server has the highest computational ability. The edge server's performance is lower, and the end device's performance is the lowest. Meanwhile, the cloud server has a longer distance to the end device than to the edge server. This is our experimental environment. We use an AI-oriented Inspire Cloud system as the cloud server, an Inspire Edge server as a non-AI edge server, and a Huawei Atlas 200D key as the edge server with AI chips. For end devices, we choose Raspberry Pi 4B, and this table shows here concrete information. We choose three applications from each scenario and running the inference. This figure shows the end-to-end inference latency of each application deploying on different layer using Edge AIBench application benchmark. From those figures, we can see for different Edge AI tasks, the best execution layer for the shortest response time are different. Therefore, for the AI workload deployment on edge computing framework, different placement or collaboration policies in handling data size and workloads across cloud, edge, and user end may substantially affect a cloud edge computing environment's overall performance. We should take an end-to-end view and use the scenario benchmarks. This figure shows three different location methods for inference on cloud cluster, edge server, and end devices respectively. The problem is which layer to allocate the given online AI inference workload can get the minimum overall response time. We perform a breakdown of each workload's end-to-end response time, processing and transmission time across three layers. From this figure, we have the following observations. We can conclude that the more simplified the workload models are, the greater influence and the transmission time has. Therefore, computing near the user may get the lowest response time. On contrary, for heavyweight workload, being processed on higher layer may lead to the lowest response time. Therefore, for the AI workload deployment on edge computing framework, we need to estimate the computation ability of the devices on different layers and the network condition firstly. Then we can decide which layer to offload the workload by trading offs between the processing time and the transmission time. Okay, let me conclude this presentation. In this talk, we introduce Edge AI Bench, a scenario-based Edge AI computing benchmark suite with four typical scenarios: ICU patient monitor, surveillance camera, smart home, and autonomous vehicle, and it has 9 application benchmarks and 9 real-world data sets. And this is our website link. Please refer to our website and paper for more details. Thank you for your listening.